Yeah. Okay, I'll repeat this problem once again. See, if any network problem is there, you can one of you can just call me, okay, to the mobile phone. Okay. Yeah. See the question here. Steam flows through the nozzle with a velocity of 450 meter per second at a direction which is inclined at an angle of 16 degree to the wheel tangent. Wheel tangent is U line. To that line, nozzle is inclined means alpha 1 is given 16 degrees. Steam is coming from the nozzle means V1 is given 450 meter per second. First sentence is clear, all of you?
Yes, sir.
Next sentence is steam comes out of the moving blades. So steam can come out of the moving blades either by V2 as in the earlier case or by VR2 tangent to the blade outlet. Steam can come out. But how it is coming out? It is coming out from the moving blades with a velocity of 100 meter per second. This point is very important whether it is a VR2 or V2. It is coming out V2 100 meter per second or coming out velocity is 100 meter per second. This it is in the direction of 110 degrees with the direction of blade motion. This 110 degrees with the blade motion tells us it is not VR2, it is V2. So you have to understand by this diagram now. 110 degrees with tangent to the blade or tangent to the wheel, the velocity of the steam is coming out. Means what? From the blade velocity U, you take 110 degrees and draw this line. So by the graph, I can understand this is V2. Correct?
Yes, sir.
So 110 degree from U line or the tangent of the blade line, you cannot take it as alpha 2. It will be alpha 2 dash. Deflection angle is given. So to find alpha 2, I will take 180 minus 110. I'll write alpha 2 as 70 degrees. So with the 70 degrees, I will take V2 as 100 meter per second because it is related with the blade motion. So related with the blade motion means it is V1 or V2 only, not VR2. Okay, that I have understood from the given problem. Next is the blades are equiangular. Beta 1 is equals to beta 2 is given and steam flow rate is 10 kg per second. Mass flow rate is given. Mass flow rate is helpful for finding the thrust and power. That 10 kg per second is given. What all we need to find out? Power developed we need to find out. So already you know the procedure. You will do it. Power loss due to friction. Some other question is there here. How the power loss due to friction we need to find out. Axial thrust already you know the formula. You can just substitute from the graphical values. Blade efficiency and blade coefficient formula is also not known to us. You can substitute the graphical values. Now how to start with and complete the graphical view. This is very important. So network connectivity is there, no? Yes. Any in between audio errors are there?
No, sir. No, sir.
Okay. Until now you understood the question.
Yes, sir.
Yeah. Now recall the values given in the question. So first you focus on the cursor where I am showing. What I'll do as a regular case, I'll mark first I'll draw a horizontal line. One 10 centimeter or 12 centimeter line for a given A4 sheet. I'll draw one horizontal line. Or you can to increase the scale what you can draw is you can make landscape graphical drawing. Okay, landscape means you can cover maximum length and scale can be improved other than drawing portrait size. So horizontal line I'll draw either on the left side or the right side. You can mark one point here. Why? Because U value in the question it is not given. So I cannot mark U in the first step itself. I have to find out. Before that, I know one point because from one point only this beta values or alpha values will emerge. So I'll mark one point here somewhere on the left side or right side. If you mark on the right side, draw V1 and alpha 1 towards left. If you mark left side, you draw V1 alpha 1 on the right side. It is left to you. Choice is left to you. Or you can draw the graph triangles below the horizontal line also. That is also correct. So alpha 1 and V1 450 meter per second and alpha 1 16 degrees. I'll draw towards right side. I'll get the tip A. And from tip A, I will draw one vertical line. This should be perfect vertical line. VF1 should be exactly 90 degree with U. U means horizontal line because U we don't know what is the value. Point is clear.
Yes, sir.
And in between V1 and VF1, we know that VR1 will come. But VR1 at what angle we don't know. So I'll keep the procedure as it is. So I completed triangle, right angle triangle, knowing VF1, V1 and this bottom line, component of V1, horizontal component of V1. Only this we understood. Next is V2 is given in the problem 100. Alpha 2 we found out 180 minus 110 because 110 is not with respect to horizontal line or not with respect to blades. It is given with respect to U. So with respect to U, if you draw alpha 2, it is 110. If I take 180 minus 110, I'll find out alpha 2 on the other side. So it is 70 degree. So at 70 degree and 110, 100 meter per second, I'll draw V2 with a given scale. So given scale means what you do, 100 divided by 50. Okay, so 100 by 50, if you find out, I'll get 5 centimeters. So 5 centimeter line you have to draw from this left side point to the tip. So this completes V1, V2, alpha 1, alpha 2 and bottom point on the horizontal line. After this, from the left tip of the triangle, you drop a vertical line up to horizontal line. You will get VF2. Once this is completed, to find U is unknown. So until you find out U, I cannot fix this point for beta 1 and beta 2. You'll agree?
Yes, sir.
So to fix this another point of U or blade speed, what I'll do is either you extend Vf2 equal to Vf2 on the bottom side, or else extend Vf1 same length from A to this horizontal line. You take vertical distance and extend Vf1 equal to Vf2 on the bottom side. Both procedure are same. Now what you do, from B to A you join this line, or else if you want reverse procedure, what you do, this VF1 bottom point you extend up to this tip V2, tip of V2, extend this VR2 until it crosses this vertical line. Crossing the vertical line at B or this bottom point, both procedures are same. Both procedures will draw one line which cuts this horizontal line at a given point. That becomes U. So measure U from this alpha to beta point. You will get 167 meter per second. Now from this point, already we know V2 tip of V2 or VF2 tip we know. VF1 and V1 tip is also known. So join VR1 and VR2. Understood?
Yes, sir.
Others?
Yes, sir.
Okay. So once you understood means graphical method, 80% problem is solved. Another 20% of problem just by equations and substituting the values. What you found out from the graphical method, we have to find out. So power developed, I will not speak. Already you know the formula M into U into delta VU. Delta VU,
Sir,
you, yes.
how does delta VF is calculated?
Delta VU in such simple velocity triangle, we are adding VU1 and VU2. VU1 is from alpha 1 point to VF1 horizontal distance. VU2 is distance from alpha 2 to VF2 horizontal distance. Understood?
The V delta VF, sir.
Delta VF. VF1 you know from the graph. VF1 minus VF2. If you take, you will get delta VF.
Okay, okay, sir. Yes, sir.
If it is turbine, if it is a pump or compressor, because question comes no for students. It may be VF2 minus VF1 also. Yes, it is for pumps and compressors, power absorbing machine. If it is there, then delta VF value will be same, but difference will be VF2 minus VF1 in that case. In turbines, VF1 minus VF2 will be delta VF. Okay?
Excuse me, sir.
Yes.
Sir, can you please explain that obtaining V2 once again on the graph part?
V2 is given in the question 100 meter per second velocity.
Okay, sir.
But which velocity is the point of question? Whether it is VR2 or V2.
Okay,
So
sir.
that is decided by 110 degree with the direction of blade motion U.
Okay, sir.
So 110 degree from blade motion U, if you draw 110 degree, this is not alpha 2, correct? This is alpha 2 dash.
Yes.
So to
Yes,
find
sir.
alpha 2, what they have done is 180 minus 110 they have taken alpha 2 as 70 degrees.
Yes.
So if this is with respect to alpha 2 and alpha 2 dash means it is V2.
Okay, sir.
This is the challenging. If this question comes means definitely you have to solve by different or this confusing challenges only.
Yes, sir.
Any other questions in the graph?
No, sir.
Yeah.
That's it.
Next is power loss due to friction. So due to friction means delta HF is not known because that is the power loss. Enthalpy loss, pressure loss, energy
Sir,
loss.
GC.
GC is one. In this book they have taken GC. In my notes, I never referred this GC. Alternate form of Euler's turbine equation, if you see, I have taken VR1 square minus VR2 square by 2 only, not GC. GC is just for converting this meter square per second square into power units. This is discussed from chapter 1 to chapter 5. Okay? So rest all equations are already discussed in the earlier steps, and using those values from the graph you can substitute and find the values. So whenever efficiency is there you write in percentage, thrust is there you can write in kilonewton, if any power is there you write it in kilowatts, or work done is there you write in kilojoules per second, or write in kilowatt. Okay.
Yes, sir.
Next problem. So see here, steam issues from a nozzle to a D level turbine means it is a impulse turbine. Okay, D level turbine is given means it is a impulse turbine at a velocity of 1000 meter per second. So 1000 means what scale you will take now? Tell me. 1 is to
100.
0.
100.
100. Yes, 1 is to 100. Why? Because in a A4 sheet I have to fix the scale between 12 or 10. So to convert that into 10, I will take 1 is to 100. So 1000 by 100 if I take, I will take 10 centimeter as the V1 value. So V1 value is given. Nozzle angle is also given 20 degrees. Mean blade velocity is U is 400 meter per second is given. So take the same scale, convert that value in centimeters. The blades are symmetrical because it is impulse turbine. If it is mentioned, you take, otherwise, you find by the graph. So, blades are symmetric, beta 1 is equals to beta 2. Mass flow rate of the steam is also given, but here value is very high. 1000 kg per hour steam is flowing, looks higher, but kg per hour we are not considering for power values and work done. This you have to convert it to kg per second. How to convert kg per second? Divide that 1000 by 3600 seconds. You will find out per kg per second. Friction factor is given. Okay, what is the friction factor? VR2 by VR1 is the friction factor. K is given zero point 0.8, because once you find out VR1 value or VR2 value in the graph, easily you can find out other values and draw the graph. Nozzle efficiency is also given 0.95. So these values are given. Questions asked is, by using graphical method, one to find out blade angle, axial thrust, work done per kg, power developed, blade efficiency, stage efficiency. So all of you know the equations, but graphical method is the our work. So again, graphical method, they have again chosen the regular procedure. So first you draw the horizontal length of 12 centimeter or 10 centimeter, and on that line you fix u, or fix one left side point A. From A, V1 and alpha 1 is given in the problem. V1 is 1000 meter per second. So to the scale means 10 centimeter. Alpha 1, we are not changing the scale of angles. So angle is 20 degree as it is. So keeping from A, you draw V1 line of 10 centimeter at 20 degree angle and get point C on the bottom side or on the top side. Both are same. This step is clear. What we did, we fixed one left side point, we drawn a V1 at alpha 1, and from A, U is also given in the problem. No need to go for alternate procedure. U is given in the problem, that is 4 centimeter or 400 meter per second. So from A to B, you mark U. Any issues with the network?
No, sir.
Yes. Yeah, here you can see now. Now I have completed V1 U. Once U and V1 is known, it is very simple for us, because from point A, I can draw one more line V2 to up to D, so that I will get alpha 2 and V2. That also I can do. And point B is also known. So once point B is known, end C is also known. So join C and B to get beta 1 and VR1. So once you get VR1, 6.4 centimeter multiply by 100, you will get meter per second. 640 meter, sorry, how much? 6.4 into 100. That much meter per second is VR1. VR1 value also you can find out. Next, see, here is the point. What you have to do to find VR2, they have given the friction factor. So VR2 by VR1 is how much? 0.8. So using that, you find out VR2 value. So VR2 is zero point 0.8 into VR1 will give you 5.1 centimeter. So find it in 100 times for meter per second. So that you draw in the graph here, VR2 value 5.1 centimeter in same angle, because beta 1 is equals to beta 2 is given in the question itself. Blades are symmetrical, equiangular blades, all are same. Now you completed VR1, VR2, V1, V2. Now from point D and C at the bottom or from the top, if you have drawn the angles from the top, drop VF1 and VF2 vertical lines, vertical or perpendicular to AB line. You will get VF1 and VF2. This problem is also simple, right?
Yes, sir.
Why? Because U value is given here. Beta 1, beta 2 relation is told. V1 is given, alpha 1 is given. So maximum risk is over. So once graphical method is over, 80% problem is over, because you can find out all the values in centimeter scale, convert that into meter per second by multiplying by 100. Now from graph, beta 1 is equal to beta 2 is given, so it is 32 degrees. Axial thrust Vf1 minus Vf2 from the graph into mass flow rate 1000 kg per hour was given, so they are dividing by 3600 to make it per second. That is found out. Work done. So work done, focus on VU1 and VU2, how it is. Depending upon the direction of V1, VU1 is on the right hand side. Depending upon the direction of V2 or VR2, direction of VU2 is opposite, left side. So they have added both VU1 and VU2, they have added into U divided by GC is 1, just one value, into 1000. Why? Because we want to write it in kilojoules, kilowatt, kilonewton, like that. They have divided by 1000. Even axial thrust, again you can divide by 1000. 0.016 you can write in kilonewton. Understood? Other students,
Yes, sir.
all of you are following. Completing the velocity triangle is only the new learning here. Other values are already, equations are discussed in one or the other chapter. You can take those values and substitute from the graph. Shall I continue? Next remaining questions are power developed. So multiply work done with mass, blade efficiency, 2U into delta VU divided by V1 square. You can find out blade efficiency. Here also it is coming around 77.6%. Stage efficiency we need to find out. So for stage efficiency, either you can take work done by the blade divided by inlet energy of the nozzle, that you can consider, or else what you can do is you can multiply blade efficiency into nozzle efficiency. So blade efficiency already we have found out 77.6, so I can write 0.776 in number. Nozzle efficiency is given in the problem itself, in the problem question. At the top you can read nozzle efficiency is 0.95, that is multiplied here to get the stage efficiency 73.72%. Alternate method, what I told, this method here. Stage efficiency can be given by work done per second, already I have found out, divided by mass flow rate given in the problem. Mass flow rate 1000 kg per hour divided by 3600, you will get in seconds. Delta H, delta H is not known, so this formula is not used there. Clear? So in place of delta H, what they have done, they have given nozzle efficiency, so they have directly multiplied both the efficiencies. We'll take this problem. Yes, I'll read the question. In a stage of an impulse turbine provided with single row wheel, the mean diameter of the blades is 1 meter. It rotates at 3000 rpm. So here, from chapter 1 to chapter last, whenever rpm and diameter is given, you find out blade speed u taking pi d n by 60. So pi d n by 60 is the first concept what you have learned in the chapter 1, from chapter 1 to chapter 5. Whenever diameter and speed is given of the rotor, you find out the tangential speed of the blades. U equal to pi d n by 60. What is U? Pi, diameter is 1 meter, speed is 3000 rpm divided by 60. If you take, I will get U 157 meter per second. Next sentence, steam issues from a nozzle, that is V1. Steam issues from a nozzle at a velocity of 350 meter per second and nozzle angle is 20 degrees. This also given, means problem is over. Anyone can solve this problem now. Rotor blades are equiangular. Also, we have seen this. Blade friction K is given VR2 by VR1 is given equal to 0.86. Also, this is solved. Determine the power developed if the axial thrust on the end bearing of rotor is 120 Newton. Only problem here is the mass flow rate is not given to find the power. Correct?
Yes, sir.
So if mass flow rate of steam is given, I would have multiplied work done into mass flow rate. I would have found out the power. But in spite of that, what they have done is find the power developed. If see this relation, how beautifully they are relating something, some outputs. If axial thrust is 120 Newton, what is power developed? Like that. So means using axial thrust, you will find out power developed. Means in between somewhere we are finding mass flow rate. Are you getting my point? So values here are maximum up to 350 meter per second. So scale they have taken 1 is to 40. In my opinion, better you take scale 1 is to 60 because values are very small, less than 500. So don't take scale less 1 is to 40. You don't take. You take more scale, or you increase the scale of the graph. So for that, what can be done? You can take that. Or 1 is to 40. I think graph will be very big. Okay, 1 is to 40 also preferred, or 1 is to 50 is also preferred. You make the graph very big so that measurement angles will be very accurate. So I think I'll not discuss how to draw the graph. Can any student shortly can explain me how to draw this graph by using these given values? Yes. What is first step?
Drawing you.
Yes, very good. U is given. I'll draw one horizontal line. On that horizontal line, I'll mark U 157 meter per second over. Next step.
V1 at 20 degrees, sir.
Very good. V1 is given. Direction you can show right side or downside, left to you. So V1 is given, alpha 1 is given. That will complete. Once tip of the V1 is known, drop this VF1 line. Understood? So VF1 line is also you can get after VF1 what to do?
VR1, sir.
Very good. VR1 I'll draw such that it should touch the other end of the U, right end of the U. If it touches, I'll get beta 1 and VR1 values. Once you get VR1, take this ratio. VR2 by VR1 is given in the problem 0.86. Find out VR2. Once VR2 is found out, okay, beta 2 I will take same because it is given equiangular. With same beta 1 and beta 2, I will extend VR2 up to that value. Is that clear? Then next is what? Drop VF2 vertical line. Then from this point of alpha 1, you just join tip of VR2 and bottom of V1. You will get V2 with alpha 2 also. So graph is clear to everyone? Any doubts? Here also VU1 is sum of VU1 and VU2. VU is sum of VU1 and VU2. Delta VF is same VF1 minus VF2. If you are finding axial thrust or this tangential thrust. Any doubts?
No, sir. No, sir.
Okay. See, from the graph they got beta 1 and beta 2 35 degrees, same. And flow velocity difference, delta VF they have got 16.7. Delta VU or sum of VU1 and VU2 they have got 319.4 meter per second. This is all from the graph. Now power developed. See the equation. Mass flow rate into U into delta VU. Delta VU is known. U is given in the problem. Mass is not given in the problem. For that, what they have told, determine power developed if the axial thrust on the end bearing of rotor is 120 Newton. What they have done? See the trick here. Axial thrust, to find out, they have taken axial thrust F into Fa equal to mass into delta Vf. Delta Vf is known from the graph. Axial thrust is given in the problem. Mass you can find out from the axial thrust relation. How much mass they found out? Mass flow rate divided by 1 is Gc. Gc you forget. Vf is delta Vf is 16.7. Then axial thrust is 120 Newton. They may change values in different problems, but mass flow rate you can find out by this equation, 7.19 kg per second. This you understood?
Yes, sir.
Now using this same mass flow rate, 7.19, you multiply with work done. You will get power developed by the shaft. So power developed by the shaft is 7.19 kg per second into 157 tangential speed of the blade into 319.4 whirl velocity sum VU sum of the given triangle divided by 1000 for kilo. So answer will be in kilowatt, 360.5 kilowatt. Simple problem. But only trick is what? Finding the mass flow rate and completing this velocity triangle, indirectly finding U using diameter and RPM. So whenever in the problem RPM is given means it is for U only. Any doubts in this problem? So only 9 students left now. Any doubts up to here?
No, sir.
Okay.
No, sir.
I'll take one more problem and last problem. This last problem, problem number two, you take it as homework because all repetition again. Okay. I'll take one last problem. This problem will take and stop the class. Just a minute. I'll check the recording. Yes, I think it is going on. Yeah. This problem using analytical, they have solved the graphical method, or directly can solve by graphical method and find out whatever is asked in the question. That's also possible. But as per our syllabus in the exam or in the IA test, it will be asked with the graphical method only. I'll read the question. An axial flow impulse stream. Axial flow itself is a chapter name. No need to worry. Impulse stream turbine has a mean rotor diameter. Again, see, diameter is given 0.55 meters, means half of the earlier question. Runs at 3300 RPM. RPM and diameter is given. Find U. Same procedure. So, tangential velocity of the rotor or speed of the rotor we are getting 95 meter per second. Over. One part is over. Means drawing the velocity triangle is direct method. Speed ratio is given. Means you take U by V1. U by V1 is 0.45. And the nozzle at the rotor inlet is, it should be, I think, nozzle angle. Okay. And the nozzle angle at the rotor inlet is 20 degrees. Means alpha 1 is given. Such that VU1 is positive. See here. VU1 is positive. Next sentence, the blade velocity coefficient CB value or friction factor is 0.91 is also given, or you can say VR2 by VR1 is given 0.91. Next all is question. What is that question? Find rotor blade angles at inlet and outlet assuming. Now see the conditions are given. First condition for maximum utilization. Second condition, the blades to be equiangular. See here, in this problem, again, condition 1, for that you have to draw a separate velocity triangle if the utilization factor is maximum. Second condition, if the blades are equiangular, what is the velocity triangle? Question B is the power output in each case. How much is the power output in each case? Separately, you have to find out. Mass flow rate is 10 kg per second for both the cases is given. Third question is the axial thrust in both the cases. So, in the question, any doubts are there? Please ask.
No doubt, sir.
Okay, so it is again, points are similar to the other problems. Only new point here I will tell you. New point what is given is speed ratio 0.45 u by v1, which will help us to find out v1 only, nothing else, because v1 is not given in the problem. One more point is condition for maximum utilization. Maximum utilization means exit velocity should be minimum. If exit velocity v2 should be minimum means v2 should be equal to vf2, what we have seen in the chapter number 2. So I will start drawing the velocity triangle. So I'll draw one horizontal line. On the horizontal line, u is known. Just a minute. Hello sir. ಹಾಂ ಸರ್ ಒಂದು ಮಿನಿಟ್ ಇದು ಕ್ಲಾಸ್ ತೊಗೊಳತ್ತೇನೆ ಮುಗಿಸಿ ಬಂದ್ಬಿಡ್ತೀನಿ 5 ನಿಮಿಷ. ಎಸ್. Okay, so on the horizontal line, I'll mark this u 95 meter per second. Take any scale, 95 meter per second, you draw it in centimeters. So as per my knowledge, if it is having a 95 meter per second, v1 how much they are getting? U is 95, 5 is 0.45, they are getting 211. So for this, I think you can take scale as 1 is to 20 or 1 is to 25. Scale you can take and can convert all the values in centimeters. All meter per second values, convert that into centimeters. So U is marked here 95 meter per second. Alpha 1 is given in the question 20 degrees. V1 how much? 211.1 meter per second. So this equation, this speed ratio will help us to find V1. So V1 is completed. So from tip what you do, drop VF1 and find out VU1. And in the question they told VU1 is positive. Yes, it may be positive or negative, depends. But what about VU2? So for the first condition, for maximum utilization factor, VU2 should be 0. No extra energy should be left in the exit side, so that V2 should be very less. V2 cannot be 0 for a turbo machine for steady flow. So what we are doing, V2 should be made VF2. So there is no VU2 and there is no value for VU2. So VU2 is 0 here. So what we are doing directly, from relation of this VR2 by VR1, where is that? Here, VR2 by VR1 is 0.91. Using that value, now I have to find out this VR2 value. Now for that, end of U is known. This is beta end. So join this point to tip of the V1. I'll get VR1 and beta 1. So using this relation, VR2 by VR1.91, you find out VR2. VR2 and beta 2 also you can find out. Okay. Once this is found out, you check the beta 1 and beta 2, whether both are same or not. So both are different for the first condition. Beta 1 is from the graph you have to check, not by analytical method. From the graph it is around 35. Beta 2 from graph it is around 34. Power developed axial thrust you can find out. Next case you see, if beta 1 equal to beta 2, how velocity triangle changes? If beta 1 is equals to beta 2, okay, in that case, what they have done? Once they found out beta 1 in this case, see here, what is beta 1? 34.9. Same angle they have taken for beta 2 also, 34.9. assuming that VR1 and VR2 are different but angles are same. If you take, what will happen, this tip of the VR2 and V2 will be inside. See here, inside. Okay, once this is inside, VF2 V2 will be outside, VU2 will be in the which direction, which will be same direction. Same direction means VU, if you take difference, I have to take VU1 minus VU2 in this special case. See the bottom side velocity triangles, how they are changing. Maximum utilization factor means V2 is axial direction. For beta 1 equal to beta 2, VU2 and VU1 both are in same direction, so they have taken difference in the power calculation. Understood? Only this is the difference. Rest all procedure is same and values will change because both the velocity triangles are different. Outlet velocity triangles are different. Is that okay?
Yes, sir.
These type of problems you have solved in chapter 2 and which is the chapter, I think, pumps and hydraulic turbines also. Earlier we used to assume such type of triangle. Once you draw the triangle, it will change the answers, like these conditions are given. So depending upon these two conditions, draw two velocity triangles. Only outlet velocity will change. Outlet velocity triangles are different. Depending upon that, the power developed, beta 1 beta 2 angles, axial thrust, okay, only these values will change. Clear? So last problem, whatever is left here, you can take it as homework. So already value you can see 1200 meter per second. So again take a 100 scale or 1200 scale and draw the velocity triangle, bottom side or top side is left to you. Okay, shall I stop the class?
Yes, yes, sir. Yes, sir.
Okay, thank you very much.
Sir, how much percentage will theory comes in?
Yes, how much?
Percentage of theory questions comes in as to sir.
Percentage of theory means, see, if we include derivation with theory, I can say around 40% to 50%, it will be derivation and theory. Around 50%
Yes, sir.
and more than 50% numericals will be there. So focus more on, and one more thing, whenever you